Hello. We were we are talking about impulse and momentum change. Relationship. Okay. So we go back to this definition of the force vector is a delta p. The p is a little p here, okay, little p, which is momentum, right? Which is linear momentum. Delta t, right? So that's where we start. So if you do this, remember P is equal to mv, right? This is definition. So this is delta m, right? So this is equal to P2 minus P1, okay? In delta t. And P2 minus P1 is m, so mass doesn't change, minus mv1, delta t, okay? So then we're going to do this now, F, right? 1. So we say F delta T is equal to P2 minus P1. It's also equal to M V2 minus V1, which is equal to M delta V. Okay? So this is the relationship that we're looking for. So we have this one here, which will be called impulse. Right? So F delta T, a force, right? Normally it's a constant here, times the delta T is the impulse. And then the P2 minus P1, which is delta P, which is so-called the momentum change. Okay, that's the momentum change right there, which is momentum change. So you can express it in terms of this because M is constant, or in terms of that. Okay, so that is a relationship that we say, but now let's show a simple example. Okay, I'm gonna clear that. Now, a simple example says the following. If I have a ball, okay, let's say if I roll it, right, roll it toward this wall here, okay? Let's say my velocity and there's no friction here. Let's assume there's no friction here. And this velocity is equal to v, okay, going this way. And then when it bounces back later, it come back with a velocity going this way, okay? And that's called a v prime, okay? Let's say v is equal to 1 meter per second. And when this come back, let's just say that this one here is equal to 1/2, okay, meter per second. Let's go in this way now. And we say m is equal to 1 kilogram, right? So according to impulse, right? So let's say the contact time between the ball and the wall, right? So the contact time, which is your delta t, let's say is equal to 10 to the negative 3 seconds. So based on this, the question is asking what is the average force that the wall give it to the ball, right? So this is the wall give it to the ball during the contact is equal to how much? Okay, so then with this kind of problem, you can say, all right, F delta T, which is your impulse, okay? I think impulse, sometimes people just say like that. So IMP, maybe even say I, okay? Just, I think that's what I'm not sure about this one, so maybe IMP, right? So that's equal to M delta V, right? So that's one way to write it. All right, so then we know F is equal to M, right? Delta V, delta T. Okay, so then that's equal to M is equal to 1. And delta V is V2 minus V1, right? And delta T, we know is this guy here, 10 to the negative 3. So what's V2? So V2 is V prime, right? So V prime here, actually, when you plug in the value, it's going to the left, okay? So you got to plug in minus 1/2, okay? Because it's going to the left, right? Be careful, it's going to the left. Important thing to say 3 times. going to the left, so minus. So got a minus sign right there, okay? And then minus V1, which is minus, and this is going to the right, okay? So we're basically saying the X positive is going to the right. So it's minus 1, okay? Right, and then this is 10 to the negative 3. And 1 is gone, right? We don't need the 1. So then this is equal to minus 1.5 times 10 to the 3 and Newton, right? So that's the force. So it's minus because the force is pushing toward the right. So that when the ball is making contact here, so I'm just drawing here, okay? I'm changing color here. The ball is making contact right there. And this ball, it's being pushed by the wall going this way. And this is the force that we, average force, right? Because the contact force may change. So this is equal to about that much, right? About, so 1.5 times 10 to the 3, right? 1500 Newton going to the left, all right? And it's negative because it's going to the left, okay? Going to the left. So you can just say, right? Pointing to the left. All right, that's all we have for today. And hopefully you get to understand the impulse and momentum change a little better, all right? And then we will see you next time.